You're listening to DTF HN for June 13, 2026. I'm Zoe, filling in for Jack today. We are your daily tech feed for Hacker News, a website where people who mass-produce opinions argue about who should control the means of production. Today's got that who gave you the keys energy. Let's get into it. What does a browser actually owe the people who use it? Not the shareholders, not the board. The people who go out of their way to download something different, because they made a deliberate choice about how they want to experience the internet. Someone just left Mozilla after 15 years. The farewell note they posted internally is remarkable. Not because it's angry, but because it's precise. They use this metaphor that I think cuts right to the bone. Imagine a town full of McDonald's, Burger King, and Wendy's. Firefox is the mom and pop diner where customers pour each other coffee and clean up tables, where you can walk up to the owner at the grill and ask why the pork chop doesn't come with rice. That's not a weakness, that's the entire value proposition. And here's where first principles matter. Strip away the dashboards and the DAO metrics and the executive strategy decks. What are the actual constraints? Firefox is a small browser. It is well funded relative to its size, but tiny compared to the browsers built by companies with functionally unlimited resources. Those are facts. The question is whether you treat those facts as a problem to solve by imitating the big players, or as a defining characteristic that tells you exactly what your community needs from you. The farewell note makes the case that Firefox's growth phase, the era when people were installing it on their uncle's laptop and their neighbor's phone, happened precisely because the community felt ownership. They weren't just users, they were participants. They told their friends because their contributions were part of what made the thing special. You cannot buy that with marketing. You cannot replicate it with a strategy pivot toward whatever Chrome is doing this quarter. One of the comments cites Pornell's iron law of bureaucracy. The idea that in any organization, the people devoted to the organization itself will eventually displace the people devoted to the organization's mission. It's a useful lens here. When the mission was build a browser for the people who want something different, every decision had a compass. When the mission drifts toward compete with Chrome on Chrome's terms, the compass breaks. This is an open source story at its core. Firefox exists because people believed that a browser should answer to its users, not to an advertising business model. The code base is open. The governance could be open. The relationship with the community could be open. Every layer where you close that loop, where decisions get made in rooms the community can't see, you lose exactly the thing that made people seek you out in the first place. The person leaving spent their careers supporting the stuff nobody else wanted to deal with. They're going to spend a few days screaming at the ocean. I hope it helps. But the real question isn't about one departure. It's whether the people still inside that building remember who they're building for. So who is building for everyone? How about the engineers who just made electric motors without rare earth minerals? I once spent weeks debugging a system where the elegant solution turned out to be removing the most expensive component entirely, not optimizing it, not replacing it with something fancier, just realizing the architecture worked better without it. That memory hit me reading about what Renault has been doing with electric motors since 2011. The conventional wisdom in EV motors is that you need rare earth permanent magnets, neodymium, dysprosium, elements with supply chains that run through a handful of mines, mostly in one country, with extraction processes that are genuinely ugly. The entire industry accepted this as the cost of doing business. Tesla uses them. Most of the field uses them. And here's Renault, quietly shipping electrically excited synchronous motors for 15 years, saying no thanks, we'll generate our own magnetic fields. Now let me play devil's advocate for a second, because the commenters raise a fair point. Electrically excited synchronous motors are not new. Industrial motors have used this principle for over a century. BMW is doing it now with higher power output on 800-volt architecture. So where's the innovation? Here's where the engineering craft earns real admiration. The challenge was never whether you could build a motor without permanent magnets. It was whether you could make one small enough, light enough, and efficient enough to fit in a consumer car at a price point that works. Renault's second-generation 6A motor is smaller and lighter than its predecessor while pushing 160 kilowatts. The Renault 5, which just won Car of the Year 2025, runs a 110 kilowatt version. The Alpine A390 stacks 3 of these motors for 345 kilowatts combined. That's roughly 470 horsepower from motors with zero rare earth dependency. One commenter nailed the most automotive engineering sentence possible from the article: replace the magnet with a controllable magnet, and that's actually the beautiful part. A permanent magnet gives you one fixed field strength. An electromagnet gives you a field you can tune in real time. You traded a constraint for a degree of freedom. The supply chain angle matters enormously. Rare earth mining is concentrated, environmentally destructive, and geopolitically fragile. Every motor that doesn't need those materials is a motor that can be built anywhere, by anyone, without asking permission from a single source supplier. Renault manufactures all of these at their Clayton plant in France. The entire production chain is legible. This is what good engineering looks like when it compounds over 15 years. Not a breakthrough announcement. Not a concept car. Iteration after iteration of a fundamentally sound architecture, refined until it wins Car of the Year. Twice. Now, open engineering is one thing. But open access to AI models is turning into a whole different fight. The top voted comment on Hacker News cut straight to the mechanism. When you spend months telling regulators how dangerous your product is, eventually someone with authority decides to believe you. In pharmacology, there's a concept called the therapeutic index. The ratio between the dose that helps and the dose that kills. A drug with a narrow therapeutic index gets extra scrutiny, extra restrictions, extra paperwork. No pharmaceutical company would voluntarily market their product as having the narrowest therapeutic index in the industry, and then act surprised when the FDA pulled it for review. Anthropic did exactly this with Fable 5. Their own launch materials emphasized unprecedented capability, unprecedented risk, unprecedented safeguards. They required 30-day data retention on all customer interactions. A policy they admitted cost them business. Specifically to monitor for misuse, they published detailed frameworks about catastrophic risk thresholds. They built an entire brand identity around being the safety-conscious lab. The directive itself is revealing in its thinness. The government cited a non-universal jailbreak, essentially asking the model to review code and identify flaws. Anthropic's own analysis confirmed that GPT 5.5 and other publicly available models produce equivalent results. The specific vulnerabilities surfaced were already known. The technique was narrow. The actual risk delta appears to be zero. None of that mattered. The government had the narrative Anthropic had spent years constructing, and it had the legal authority to act on it. 5:21 p.m. on a weekday. No specific details provided. Comply immediately. Several commenters noted the downstream precedent. If a closed-source model can be shut off by directive, no public review, no technical specificity, no appeals process visible in the letter, then every closed-source model operates at the pleasure of whoever holds regulatory authority that quarter. The capability didn't change between 5:20 p.m. and 5:21 p.m. The permission did. Open-weight models don't have this failure mode. You cannot issue a directive to suspend access to weights that already live on 10,000 hard drives across 40 countries. The architecture is the policy. Anthropic built a system with a single off switch and handed the government a map to it. The therapeutic index was always real. The question was never whether the drug was dangerous. It was who gets to decide the dosage. Moving on. Every project management tool you've used was designed around a single assumption: only humans do work. The entire data model, assignees, watchers, reporters, assumes a person on each end. Paca throws that assumption out and rebuilds from the foundation. The technical problem is genuinely interesting. When you bolt an AI agent onto Jira, you're grafting a fundamentally different kind of worker onto a system that models collaboration as ticket assignment and status updates between humans. The agent becomes a second-class citizen. A chatbot in the sidebar, an automation rule that fires on triggers. It can't pick up a task from the sprint board the way a developer does. It can't update its own status. It can't participate in planning. Paca's architecture treats AI agents as peers in the Scrum process. They show up on the Scrumban board. They pull from the backlog. They collaborate on BDD specs and system design documents alongside product owners and engineers. The data model was built for this from day one. This reminds me of what happened with version control in the early 2000s. CVS and Subversion were designed around a central server model. One truth, linear history, lock-based collaboration. When Git arrived in 2005, Torvalds didn't patch distributed workflows onto a centralized architecture. He started from the constraint. Thousands of kernel developers working asynchronously across time zones. And built a fundamentally different data structure. The Merkle tree of commits, the DAG. Every clone is a full repository. The architecture encoded the collaboration model. Paca is doing something analogous for project management. The plugin system deserves attention here. Back-end plugins compile to WebAssembly. Write them in Go, Rust, assembly script, anything with a WASM target. They run sandboxed with capability-based permissions, declaring exactly which host functions they need. Front-end plugins are standard module bundles. This is serious engineering. The WASM sandbox means community plugins can't reach beyond their declared permissions, which is how you build a plugin ecosystem that people actually trust. And it's Apache 2.0, self-hosted, free. Your data stays on your hardware. One comment on the thread caught my eye. Someone built something similar for themselves but said it got too personalized to open source. That's the classic trap. You solve your own problem so precisely that the solution becomes a mirror of your workflow rather than a platform. Paca sidesteps this with configuration-driven everything. Workflows, statuses, field definitions, board layouts, sprint rules, agent behavior. All project-level config files. No code changes to adapt it to your process. The PSEA cycle. Plan, act, check, adapt. Maps cleanly onto both Scrum and the scientific method. That's not an accident. Complex domains require probe, sense, respond, not predict and control. When your AI agents are inside that loop rather than outside it, they can adapt to emerging complexity the same way a good engineer does. The tools exist. The architecture is right. This is how open source wins. By building what the incumbents can't, because their business model won't let them give AI agents a real seat at the table when they're charging $20 per seat per month. Now, if you want to talk about agents that adapt to complex systems, let's talk about CRISPR going after cancers we couldn't even touch before. In 1995, Sun Microsystems shipped Java with a feature that scandalized half the systems programming world: automatic garbage collection. The prevailing wisdom was that you managed memory by hand, you tracked every allocation, you fixed every leak. And Sun said, no. You find the broken references and you destroy them. Don't fix, destroy. It was heresy. It also worked. 30 years later, a team at UC Berkeley just did the same thing to cancer biology. For decades, the oncology field has been trying to fix page 53, the tumor suppressor protein that's broken in nearly half of all cancers. 70 to 90% of pancreatic, ovarian, and non-small cell lung cancers carry this mutation. It's been a premium target since the late 80s, and in all that time, not a single page 53 targeting drug has made it to market. The protein has no druggable pockets. There's no keyhole to fit a molecular key into. Researchers have been trying to patch corrupted memory by hand, and the architecture won't allow it. Jinken Zhang, a postdoc in Jennifer Doudna's lab, asked the question that the field has been politely stepping around: what if you stop trying to fix the broken cell and just kill it? The approach is called chromatin shredding, and the deadpan elegance of it is almost funny. They engineered a CRISPR system, Cas12a2, that scans for the specific RNA transcript produced only by cells carrying the page 53 mutation. When it finds one, it doesn't edit, it doesn't repair, it shreds the chromatin. The cell is gone. In bacteria, this mechanism evolved as a suicide switch, a cell destroying itself to stop a viral infection from spreading. The team just pointed that same self-destruct sequence at cancer. The paper is in Nature. The preprint has been up for a month, and as one commenter noted, the concept of mutation-triggered cell killing isn't new. Previous attempts used Cas9, which just damages DNA. Cas12a2 is indiscriminate once activated. It doesn't nick, it shreds. The real question nobody wants to sit with: this system is programmable. Doudna's quote is precise. They can adapt it to new mutations easily and quickly. That means the targeting logic is software, not hardware. You're not developing a new drug for each mutation. You're updating the search pattern. The research is open. The mechanism is published. The tools exist. And the garbage collector doesn't care how long you spent debugging by hand. Now, from rewriting biology to rewriting narrative itself. Story 6 has a shadow over it, and it's worth pulling apart. 5:21 p.m. on a Friday. That's the timestamp on the US government's directive to Anthropic ordering them to kill Fable and Mythos for every user on Earth. If you've ever worked in communications, you know exactly what a Friday evening announcement means. You're not trying to inform people. You're trying to outrun the news cycle. The official justification is a jailbreak. Someone apparently found a way to coax Fable into identifying some security vulnerabilities. Anthropic reviewed the technique and says the vulnerabilities were minor, previously known, and reproducible with other models including GPT 5.5. The government's letter didn't even include technical details of the national security concern, just the order, shut it down. Run this forward. A government agency, citing Export Control Authority, can now disable a commercial software product used by hundreds of millions of people based on an unspecified security claim, with no public evidence, no review process, and no advance notice. The mechanism isn't a court order. It isn't legislation. It's a directive delivered after business hours with immediate compliance expected. The foreign national framing is the tell. The order technically targets non-US persons, but since Anthropic can't verify citizenship at the API level, the practical effect is a universal kill switch, which the government knew when it wrote the order. One commenter's instinct was immediate. This is about establishing precedent. The jailbreak is the excuse. The capability being demonstrated isn't Fable's, it's the government's. The ability to reach into a company and turn off a model for everyone, worldwide, in hours. Anthropic's response is worth reading carefully. They complied, but they published a statement saying they disagree. They named a competitor's model as equally capable. They committed to sharing details within 24 hours. That's a company trying to build a public record while following the law, which is about as much resistance as a corporation can mount without getting sued. The answer to a dangerous capability has never been to pretend it doesn't exist. The jailbreak techniques, if real, work on other models too. Pulling Fable doesn't eliminate the capability. It eliminates Anthropic's ability to compete while the capability persists everywhere else. The people who actually need to find vulnerabilities. Defenders, researchers, red teams. Just lost a tool. The people the government claims to be worried about still have 5 alternatives. The off switch worked. The question is who it worked for. Moving on. Ahmed Osman's site fits on a single screen. No logo, no sign-up form, no pitch deck. Just a thesis statement and an email address. The thesis is 7 paragraphs long and every sentence is load-bearing. Here's the line worth reading twice. If intelligence becomes something people can only rent from a few closed institutions, the public does not just lose software freedom, it loses operational freedom. Operational freedom. That word choice matters. He's not talking about developer convenience or hobbyist tinkering. He's talking about whether a hospital can run a diagnostic model without checking with a vendor, whether a school district can deploy a tutoring system that doesn't phone home, whether a country can maintain its own intelligence infrastructure the way it maintains its own power grid. The document reads like an engineering requirements spec for civilization. AI must be usable, understandable, reproducible, locally deployable, economically viable, and community governed. 6 constraints. Each one is a design decision that most frontier labs have already failed. You can't reproduce a model you've never seen the weights for. You can't locally deploy something that only exists behind an API. You can't govern what you can inspect. One commenter raises the hard question, who funds this? Training costs are real. The 2 obvious funding sources right now are venture capital seeking returns and state actors seeking influence. Neither optimizes for openness. But this framing assumes the current training paradigm is permanent. It's not. Efficient architectures, distillation techniques, synthetic data pipelines, and commodity hardware are all compressing the cost curve. The expensive part isn't staying expensive. The expensive part is becoming a solved problem while the governance part remains unsolved. The real risk isn't that open source AI can't match closed models on benchmarks. It's that the window for establishing open infrastructure closes while everyone is still arguing about who pays for the next training run. Once cognition is a subscription service controlled by 3 companies, the switching costs become civilizational. You don't get to rebuild that from scratch. Osman ends with 6 words, send a quiet note, no manifesto, no movement, just one person who looked at the architecture and saw what it implies. The tools exist. The question is whether we build the open version before the closed version becomes the only version. Now for something completely different. Turns out the most dangerous AI model in the world made a video game, and it's actually delightful. Let's take the dangerous AI argument seriously for a moment. A model so capable it can synthesize 2,300 lines of working code from a single natural language prompt. That is a genuine shift in who gets to build software. If you've spent years mastering JavaScript game physics, watching someone conjure your entire skill set with a paragraph and €20 should feel threatening. The most dangerous model framing isn't wrong because the capability is trivial. It's wrong because where the danger actually points. Follow the logic all the way. If this model is dangerous because it democratizes creation, then every tool that ever lowered the barrier to making things was dangerous too. Compilers were dangerous to assembly programmers. WordPress was dangerous to web developers. Spreadsheets were dangerous to accountants. Run the principle to its conclusion, and you arrive at a world where literacy itself is the original sin. The moment you taught people to read, you destroyed the scribe's monopoly. The argument devours itself. Now look at what Cohen Van Gilst actually built, a sheep herding game. The kind of idea that lives in the back of your mind for years because the activation energy of learning canvas physics and flocking algorithms and input handling was always just slightly too high. One prompt, one file, zero dependencies. And the thing that catches my attention from the comments is a person with actual herding experience saying the sheep movement is excellent and suggesting improvements based on real flock behavior. The model didn't just generate code, it encoded something close to accurate ethological simulation. That's craft worth admiring. 2,300 lines of coherent, playable, dependency-free HTML is not a party trick. It's a compression of genuine engineering knowledge into an artifact that someone with no programming background can prompt into existence. The most dangerous AI model in the world made a game about a dog and some sheep. And the game is good. The tools exist. The gatekeepers just lost another gate. So AI can build a whole game from scratch. But what happens when it turns its attention to finding holes in the software we already depend on? How long can a bug hide in code that everyone can read? FMPEG is open source, 1.5 million lines of C, publicly available for over 2 decades. Google has thrown teams at it. Anthropic pointed their unreleased Mythos model at it. Fuzzers have been hammering it continuously for as long as fuzzers have existed. And a company called Depth First just pointed an autonomous security agent at the same codebase and pulled out 21 previously unknown vulnerabilities. Several had been sitting there, latent, for 15 to 20 years. The numbers deserve clinical attention. Google's Big Sleep project found 13 vulnerabilities. Depth First's agent found 21, including issues the other efforts missed entirely. The cost, roughly $1,000 in compute, compared to an estimated $10,000 for comparable manual analysis. And these aren't theoretical findings. The agent produced concrete, reproducible proof of concept inputs for each one, confirming exploitability by execution. One finding in particular warrants precision: a heap buffer overflow in the RTSPHEVC depacketizer that the team developed into a working remote code execution primitive. Any deployment pointing FMPEG at an attacker-influenced stream URL. Media ingest pipelines, surveillance systems, transcoding services. Is exposed. FMPEG processes media in virtually every browser, every streaming platform, every video tool you've touched this week. The architecture of this agent matters. It isn't prompting a model and reading the output. It threat models the codebase, maps attack surfaces, traces data flow from attacker-controlled input to vulnerable sinks, then branches into parallel hypotheses and validates each one with generated test harnesses. The artifact isn't a report, it's a confirmed exploit. The comments raise a fair objection: finding bugs is easy compared to getting them fixed. That's true, and it's worth sitting with. But the capability curve here is unmistakable. An autonomous system, built on publicly available models, scanning publicly available code, finding what dedicated human teams and proprietary systems missed. For a tenth of the cost. The source code was always open. The question was always who had the tools to read it deeply enough. That barrier just dropped by an order of magnitude, and anyone can build the system that did it. Now for something completely different. Your old phone gathering dust in a drawer? It might be ready for its second act. Every system I've ever built eventually hit the same wall: not enough compute, too much budget. You start optimizing, shaving cycles, compressing models, and the whole time, there are billions of processors just sitting in drawers. Literally billions. Google Research published a paper on turning retired smartphones into cloud computing nodes, and the engineering case is stronger than you'd expect. Modern phone processors. The performance cores, specifically, match or beat server cores in single-threaded workloads. The gap isn't capability, it's scale. A server gives you dozens of beefy threads and hundreds of gigs of RAM. A phone gives you a handful of heterogeneous cores and 8 to 12 gigs. The research challenge is workload decomposition. Breaking tasks into pieces that fit the memory envelope of a single handset, then orchestrating thousands of them. Strip this to first principles. What does a data center actually provide? Processors, memory, storage, networking, power management, and cooling. A smartphone has 5 of those 6 built in, plus its own battery as a UPS. The cooling problem inverts. Phones are designed to dissipate heat passively in your pocket. At scale, the energy math gets genuinely compelling. You're amortizing embodied carbon that's already been spent. Every phone computing in a rack is a server that didn't need to be manufactured. Now, the comments land a direct hit, and it's worth hearing. The reason those phones are in drawers is locked bootloaders and proprietary firmware blobs. Manufacturers deliberately kill software support to drive upgrades. Google is proposing to harvest compute from devices whose premature obsolescence Google's own ecosystem engineered. The fix isn't just clever orchestration software. It's unlocking the bootloaders so anyone can run whatever they want on hardware they own. The person in the comments running a Docker swarm on Raspberry Pis, mounted in an IKEA picture frame already gets it. The compute is everywhere. The engineering is sound. The only thing standing between e-waste and a distributed supercomputer is permission. And that permission shouldn't be Google's to grant. This has been your daily tech feed for Hacker News for June 13, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voice by Apple Zoe. Not affiliated with Hacker News or Y Combinator. Now go build something that belongs to everyone. We'll see you back here tomorrow.